I'm going to breeze through these motion graph questions. I'll refer to rules that we have to know and understand. I won't explain all of those rules, so if something doesn't make sense, send an email or go reference your notes or find an answer somehow. You do a Google search, do something to find yourself an answer. Before I get started, I'm going to make sure I see what's on each y-axis. Here I have velocity. This one is position. I also like to make tick marks. They're fake marks. They're not real. I'm going to make up values of positive 10 meters per second. That's my go-to made-up number. And negative 10. Here I will put 0 meters per second to remind myself. On this axis, I would put position of positive, I'm out of room, hang on, positive 10. This is a nice trick. Do this on your test, right? When you see a graph, remind yourself what the values would be. Here's 0 meters, a position of 0 meters away. Okay, part A, state where the object is moving. Look at the y-axis. To move, velocity would be not 0 because you're moving. Where do we have not 0 velocity? A, B, C, E, F, and G. None of them are at the 0 line. Now let's turn to the position graph. To move, what has to happen with position? To move, position must change. So the line will have to go up or down the position axis. Which lines have a changing position? H, the graph goes up, position goes up. J, position goes down. L, N, and O. But it's a different reason. It's not the same. It's because I'm thinking about the fact that position changes. That's why they're moving. Notice what I did. When I justify my answers, I reference the y-axis. When I justify those answers, I reference the y-axis. If I try to reference the wrong y-axis, I'm gonna get myself into trouble. So make sure you remember which graph you're looking at. Okay, on to the next one. Let's delete this. Where is the object moving leftward? I know that that's A, B, and C because that object always has negative velocity. I also know it's J and L because the position is decreasing. Let's go through those more slowly. A, B, and C. When I say that these are negative values of velocity, the negative means to the left, and the velocity means it's moving to the left. A all has negative everywhere on that line. The y value, the velocity, is negative. Same for B, same for C. So all of those have negative velocity at every moment. Negative means moving to the left. How about the position graph? Well, what does it mean for position if you're moving leftward? If you're moving leftward, think about a number line, right? Here's my number line. 0, -2, -4, -6, +2, +4, +6. Here you are, standing at a positive position, but you're moving to the left. Your position is decreasing. You're going like from +3 to +1. That's a decrease. And when you get over here, you're still going left. Your position is still decreasing. From -2 to -4, that's a decrease. So J has a decreasing position because we're going down the axis, down the y-axis. And L has a decreasing position. We're going down the y-axis. from like, -2 to -10. So that's J and L, because position decreases. Alrighty, onward and upward, or downward maybe, I don't know, depending on the sign of your velocity. Okay, on to C. Where is the object moving rightward? Here, for a velocity graph, you're moving to the right if velocity is positive. E is up in the positive half of the velocity axis. F, G, all of those, because velocity is positive. How about the other graph? We are moving to the right. Think about the number line. Here's my number line. -4, -2, 0, 2, 4, 6, 8. You're moving to the right, that's this way, if your position is increasing. H has an increasing position, O has an increasing position, and so does N. All of those are moving up the y-axis, up the position axis. H, N, and O. Position increases. Where are we not moving? All right, get this away. We're not moving. Well, let's look at the velocity graph. How do we not move in terms of velocity? You're not moving if velocity is 0. D is the only one that's on a y value, a velocity value of 0 meters per second. How about position? You're not moving if your position stays the same, if it's constant, if it doesn't change. Where do we see a position that stays the same? I. Position doesn't go up or down. Likewise, K and M. Oops. I, K, and M. Position stays constant. Position doesn't change. Where are we located to the left of the origin? Now for this E and F, you cannot answer with any of these. We simply don't know. There's not enough information. Because, if you're moving to the left, that doesn't mean you're located to the left. I could be, here's my 0. I could be moving to the left and located over here in positive position land. So you can't tell what the right answer is from the velocity graph. We don't have enough information. So let's focus just on the position graph. You're located to the left if your position is negative. The negative means left, and the position means where you're located. So the answer would be any negative positions. That's going to be L, M, and N. Position is negative. You're located to the right when your position is positive. That's H, I, J, and O. Position is positive. So just to clarify, a negative position means you're located to the left. A negative velocity means you're moving to the left. The negative sign means left, but it has different implications. Here, you're just standing to the left of some reference. Here, you're actually traveling or moving to the left. Okay. Where are we located at the origin? That would be when our position is 0. And what part of the graph do we have on the 0 tick mark of the position axis? Just K. Okay. Part H. Where are we accelerating? Let me first turn to the velocity graph. To accelerate in terms of velocity, velocity must change. Because after all, acceleration is defined as the amount of change per second, or per unit time. So look at your velocity graph. Where do you see the y-axis, the velocity axis, changing? Here, the velocity is going down. It's changing. Here, the velocity is going up. In E, the velocity is increasing, it's changing. And in G, the velocity is going down. We're moving down the y-axis. So the answers there are A, C, E, and G. How about the position graph? Now we're going to use the same rule for the position graph. Get these all away. We will still look for spots where velocity changes, but on a position graph, velocity equals slope. So instead of looking for where the velocity changes, just look for where the slope changes. The only line that you see, the only single line on this graph that has a changing slope is O, because the line is curved. The slope, the velocity is changing. And on these first four, we said they were acceleration because velocity changed. Okay, for I and J, we can only answer using the first graph. You won't be asked whether O, you're not going to be asked whether it's positive or negative acceleration. So for I and J, let's just look at the first graph. Where do we see positive acceleration? Well, here's the equation. If your velocity increases, then the change is positive, which makes the acceleration positive. Let's say that again. If velocity increases, acceleration is positive. Because remember, we saw examples where we said every 2 minutes, maybe the velocity increases positive by 4 miles per hour. The positive here, which makes the acceleration positive, this positive means the velocity is increasing. So on this velocity graph, what does it mean to have positive acceleration? It means v increases. I see velocity, we're going up the velocity axis during C and during E. So the answer is C and E because velocity increases. We move up that velocity graph. How about part J, negative acceleration? Well, it's a very similar rule. If the velocity goes down, the acceleration is negative. And that's true for, let's see, in A, the velocity is going down, so it's decreasing. In G, the velocity is decreasing as well. So the answer is A and G for negative acceleration. A and G have negative acceleration because velocity decreases. Where is there zero acceleration? Well, let me think back to my rules, to my equations rather. Where is acceleration zero? Acceleration zero is zero if there is no change. If this is all zero, because the velocity doesn't change, that's how we get zero acceleration. Where do we see a velocity that doesn't change? On the first graph, it's B, the velocity doesn't go up or down, and D, and F. On the second graph, where do we see the velocity not change? H, I, J, K, L, M, and N. Because the velocity equals slope, those lines all have constant slope because they are straight. Thus, they have constant velocity and no acceleration. So that's how we work through those ones. What did we say? B and D and E, F. because velocity doesn't change. Change. There's my shorthand for change. And on the other one, it's H-I-J-K L-M-N because the velocity / slope doesn't change. Those are straight lines which have constant slope. All right, thanks for watching.